So now let's find another way to explain the differentiation which is closer to what we will be using in calculus on the long way. So we're using limits of average quotient. We learned average quotient on the side and we found his equation, as you remember. Now we need to know how does the differentiation is using limits of average quotient to find the differentiation of a certain function. So we define the tangent line. So we're trying to find the tangent line for the point P. We have a curve in here and we signed up some points along that curve called Q1, Q2, 3, 4, and P. We're interested in P, that's our point. So the line of tangent, or the tangent line here, contains point and has to stop where the limit of the slope of the secant line, those are secant lines, as the point Q approaches to P. So you have point P, you can draw unlimited number of secant lines as long as they're crossing the curve, but you don't know which one of them is the closest to P. So you let the point Q, as the secant line starts from P, crossing the curve, you call that intersection Q. You have Q1, Q2, 3, 4, 5, and you keep doing that to get Q as close as possible to P. Whenever you reach that, that's called your tangent line. And the slope M in this case represents the instantaneous rate of change of P. So you have the curve here, you have point P here that we talk about, and we have point Q here. The secant line in blue have a slope, and that slope, as you remember from the average quotient, the slope equals f of x plus h minus f of x over h, based on those parameters. And that curve, as we talked about as representation of P and Q points, in this way the slope M equals the limit as h approaches to 0 of f of x plus h minus f of x over h. And that's the differentiation for that function. So M, or dy over dx of that function, equals the limit as h approaches to 0 of f of x plus h minus f of x over h. If we have a definition for the differentiation using the limits of average quotient, as a function y equal f of x, it is derivative at x is a function f prime of x defined as f prime of x, or dy over dx, equals the limit as h approaches to 0 of f of x plus h minus f of x over h, knowing that the limit exists. If f of prime exists, then we say that f is differentiable at x, and we sometimes call f prime the derived function. So you have x and f of x in here. F of prime of x is the slope at the point x and f of x. As we said, we are drawing secant lines for a certain point on the curve. We don't know, we have infinite number of secant lines. Which line represents the differentiation of the curve? We use the quotient, the average quotient principle. Take the limit of that average quotient, will give you the slope at that exact point, which means the differentiation. So the main three steps for calculating derivative using the average quotient: you write the difference quotient in this case, and difference quotient is f of x plus h minus f of x over h. Then you simplify the difference quotient as much as possible for easy calculations as moving forward for the limit. Then you find the limit as h approaches to 0. That's it. You will find the differentiation of that function using the difference quotient. Now let's take some examples on that. Let's assume you have f of x equal x squared, and you need to find the f prime of x. And you need to find as well f prime of minus 3 and f prime of 4. Let's start with finding f prime of x. We know that f of x plus h minus f of x over h as the difference quotient equals, replace x plus h instead of x, and replace x instead of x here. So you have x plus h squared minus x squared over h. Simplifying that, you need to distribute this square in here on that parenthesis, and you end up with 2xh plus h squared over h, gives you finally 2x plus h. So the f prime, or the derivative of the function x squared, equal 2x plus h, where h doesn't equal 0, but it is a certain constant. So mainly you evaluated f of x plus h and f of x in here. You plugged in f of x plus h whenever possible, and you substituted the x squared instead of f of x and simplified. Then you ended up with a solution of the differentiation of that function. Limit for that differentiation, which is 2x plus h. So the limit as h approaches to 0 of 2x plus h gives you the differentiation of that function. Another example, we have f of x equal 3x minus 4. Find the f prime of x and f prime of 2. So you follow the steps. You find the difference quotient first, and you simplify it. Then you end up with number 3. Now substitute for the limit of, as h approaches to 0, of 3. As we know from the limit properties and equations, the limit of 3 equal 3, and 3 is constant. So f of x derivative of 3 in this case. And if you want to substitute f prime of 2, you have no variables to substitute 2 in it, so you still have the f prime of 2 equal 3.